Yes.
Great. So, did you uh, did anything at home?
Yeah, I just tried some command of Linux.
Okay,
Yeah, and
great,
plays. Yeah.
great. So, do you have any problem? Are you
Uh,
facing any
Not
problem?
really.
No.
Not really.
Okay, great. Sounds good. So, today I'm going to teach you a very important things. Okay, I'm sharing
Okay.
my screen. Okay,
Okay.
today the voice is quite good, huh?
Yeah, I think it's better now.
Oh, great. Can you see my desktop?
Yes, I can.
Great. So today I'm going to teach you about the board, okay, about the U-boot,
About.
about the any board, okay, any
Yeah.
SoC, the ARM SoC. I'm going to teach you about the ARM SoC and the U-boot and how to compile the U-boot and how to load the U-boot, okay, and several things. It's very very important if you are working with a Linux and if you want to work in an embedded system, okay. So
Okay.
agenda is we'll pick some board, okay, and on the basis of board we will compile the U-boot and we will do a setup of cross toolchain, okay, and we will flash the compiled binary on the target, okay.
Yeah.
So
Okay.
right now I have some board, okay. I want to show you what kind of board I have, okay. Do you know about the IMX6 processor? Do you know anything about the
MX.
IMX6 processor? IMX6. It's an ARM device from Freescale. Now it's NXP
Uh,
because
I
Freescale.
don't know.
Yeah,
Yeah.
you don't know. Did you know anything about the ARM?
What? Yeah, I know.
It's the same thing. Okay,
Yeah.
the same core is that.
Do I need to buy this ball?
Uh, it's all on you. If you want, you can buy. Okay, and if you have another board, we can work on that board also. Okay, if you want, if you don't have, you can buy this board. Okay, or if you have another one, some earlier board, we can work with that. Okay, it's not necessary.
Yeah. All right.
Okay, so this is the core. It's ARM core only. Okay, Cortex A9. Okay,
Yeah. Okay.
it's a very latest chip. Okay, inbuilt with the GPU. So if you want, you can read these documents. If you want to more know about the the SoC, it's better. Okay, so right now we have a processor that is called Dual Light, IMX6 Dual Light.
M6 Udula.
Dual
Yeah.
Light. It's ARM core. Okay, this is the core. Okay, it's better. It would be better if you are going through these documents. These are very important. So this is the board. Okay, right now I have, and the agenda is we will download the U-boot. Okay, source. and we will set up the tool chain, and we will compile it, and we will generate a U-boot image, and then we will load the U-boot image on the board. Okay.
Okay.
It's a very first thing when we are working with any board, or we want to write our own U-boot, or do you know this process is specifically called what? You have any idea about it? This process is called
No.
BSP. Do you know about the BSP? BSP.
BSP,
BSP.
Ball Support Package.
Yeah, yeah. We are going to do the same thing, okay?
Yeah.
Great. So here is the source code. Did you saw any time the source code of the U-boot? Did you got the opportunity to saw any source code?
Sorry?
Did you saw any time the source code of the U-boot?
No.
This is the source code of the U-boot, okay?
Okay. Can you explain what is U-boot? I don't know about it.
Uh, U-boot stands for Universal Boot, okay? Universal Bootloader. So some open community design this, source code. It's open, okay? It's copyleft. It's not copyright. So anyone can use it. If you are designing your own board and you have to do several more modifications on the basis of your memory, on the basis of your peripherals, devices, and you can use this utility or this source code for your own board. The every board is different from another board. There are several chips, and there are several peripherals. There are several different peripherals. There are several different chipset.
Yeah.
So we try to enable the peripheral support, the buses, support of the buses, support of the devices, support of the memory, several things, almost everything. Okay, and
Yeah.
that process is called the BSP, board support package. Okay, you are writing your own U-boot for your own target, a specific target, your designed board. Are you getting my point?
Yeah.
Let's say there are some hardware guys. Okay, they are designing some a specific board SoC with the SoC ARM SoC for some specific purpose. Okay, the software guy have to write some U-boot, the primary bootloader. Okay, that is called the primary bootloader to initialize the the memory, the peripherals, the devices, the buses, and everything.
Yeah.
So that is called the U-boot.
All right.
Yeah. So this is the generic source of U-boot. Okay, and we are going to optimize this source code for this specific target. This one. Okay.
Okay.
So you know already about the cross compilation. I think I told you about
Cross
this.
comparison.
Yeah. The ARM tool chain is already set up in the my PC. Okay.
Okay.
So there is a ARM tool chain already working in my PC. If you want, you can also set it in your PC. Okay. So what I will do, I will write some shell script, okay, to compile it.
Yeah.
But I have already the shell script. Do you know what is the shell script? Do you know anything? What is the shell script?
About what?
Do you know anything about the shell script?
No, no.
Okay.
To
Uh,
copy.
a shell script is a collection of commands. Okay, we have a several commands in a Linux. If you want to club all the commands in the single file, and if you want to execute it sequentially, it's called the shell script.
All right.
So I'm going to write a shell script that is called nam.sh. Okay, there are several extra lines which is not required. Okay, so now the script is ready. Okay, the first line is saying that we are going to compile our source code for the ARM architecture. Okay, can you see
Yeah.
the first line? Okay,
I see.
yeah.
Okay. Do I need to repeat your step?
No, because right now you don't have the source code. Okay, you need to download it.
All
Okay,
right. Yeah.
so you cannot do this. So just I'm giving you an idea about this. Okay, and the later on,
Okay.
if you arrange your board, we'll doing this again. Okay, for you. Okay,
Okay.
or you can try alone. That would be a good idea. So the first step, we are going to compile it for ARM. Okay, the second is we are going to use this tool chain. Okay, you know
Yeah.
this is the tool chain. Can you see the same I am using? Yeah, it's okay.
Yeah.
Echo just to show you, it's nothing with the compilation. If you want, you can erase it. But just for visibility, I did this step. And this is your U-boot directory where all the source code are kept. Okay,
Okay.
and
Yeah.
this is command. If you, we are cleaning all the earlier .os file and the binaries, which is not required for us. Okay, then we are configuring the all the source code for our SSC and board, and we are making it. Okay, once it's configured for our SSC, we will make it. And J4 stands for we want to use the all the processors, all the core of uh, the host machine. I want to make it so it would be a very fast. Okay, and I want to copy the compiled images to this directories. Okay,
Okay.
so what I will do, I will execute this command. Okay,
Okay.
okay, so it will take few minutes. Meanwhile, I will connect the board with the PC. through the UART and through the OTG cable. Mhm. Sorry. It's clear. So I'm connecting, okay? So compilation is done, okay? Hello? Hello?
Okay.
Compilation is done. So I'm going to connect the board. This was for OTG and this was for a serial, okay? So it's connected with the TTY USB 0. Can you see? Okay,
I see. Yeah.
yeah. And I want to check that there is another cable that is for OTG. It's connected or not. So we'll use some another. Yeah, there is a scale, okay? Can you see?
Yeah, I see.
Okay. Do you know the minicom? What is the minicom? Do you know anything about the minicom?
No, no. What is that?
Minicom is a serial console, okay, in a Linux machine. If you want, you can use it. Do you know putty? Do you know putty in a window? This one,
Booty? I don't know.
this one. No, no. These are the tools to,
Booty.
yeah, these are the tools to see the serial console, okay?
Okay.
Do you know we saw this, device node, TTY USB, okay? It means it's connected with the this device, okay? The serial is connected with this device. There is nothing,
Yeah.
okay? There is nothing because the board is empty. There is no source code on the board, okay?
No source code on the ball. Yeah.
Yeah. Here is a U-boot. Just we compiled it. Okay. Just right now we compiled it, okay? So we're gonna load this. There is a loading utility, okay, that will help us to load the source code, okay? This is the loading utility. Can you see it?
What is that?
This is a tool which will be loading from your host machine to the target. Right now we have images here, okay, but we have to execute this image on this board, okay? So right now I have images in my PC, but I have to execute these images on the board. So how are we doing this? We have to load this image into the RAM memory of this board.
Into the RAM memory.
Yeah, RAM, the random access memory of this board. we're doing with this utility. Okay, we kept these images here. Okay,
Yeah. Okay.
I will explain it again. Okay, it's loading. Somehow, unfortunately, it's failed. Oh, it's successful now. See here, it should come with the U-boot. No. Okay, what I will do, I will reset it, reset the board, all the connections. Okay, see here. Oh my God, it's again. So let me check it's connected properly or not. Yeah. Can you see?
Yeah.
Yeah. There is a U-boot, okay? And this is called the U-boot prompt. The U-boot prompt.
You boot from.
Yeah.
Okay.
From here you can configure several things. Did you heard about the boot from SD card, the NAND memory, boot from NFS, the several things we can control from here. Okay,
Yeah.
we can configure the IP, we can configure the TFTP boot, NFS boot, the boot from NAND, boot from NOR, boot from SD card, boot from USB. Did you heard about these things earlier?
No, no.
Okay,
Can you
so
expand a little bit more on?
there are several kind of booting strategy. Okay, those are called
Okay.
the NFS boot, the TFTP boot, boot from NAND memory, boot from SD card, boot from USB. The several techniques we have, and that we can configure from here. Okay, so we are here.
Okay.
We are here on the boot prompt, and there are several commands. Like if you want to change the IP, you can configure the IP. Let's say I'm changing the IP, set env IP server IP 208.186. Okay, the earlier server IP is this one. Okay, can you see?
Yeah, I see.
Yeah. So I'm going to change it. It's changed. It's changed.
Yeah, yeah.
Yeah. I will I will brief you again this process. Okay, it's very important. Okay, I'm going to compile it again with the bit modification, and that modification is I'm going to change the this U-boot prompt name. Okay, do you know you can configure anything from this file? The baud rate, the
Yes.
ports, the speed, the stack size, the RAM size. Okay,
Yeah.
now I'm going to change the boot prompt. Okay, we'll compile it again. With this compilation, we are generating the U-boot, the primary boot for our target. Okay, and with the loader utility, we are loading that compiled image into the RAM memory of the board, not on the flash memory. So when you will reset the board, the all the code will be void. Okay, it's
All the code be gone because
yeah,
it's stored in
yeah,
RAM.
it's a property of the RAM. Okay, once it's the power is gone, there is no code. So still the power is here, so we are able to check it. What I'm going to do, I'm resetting the board. Okay. So
Resetting the ball.
yeah, there is no power, so there is no code. Okay. It's not working right now.
Okay.
It's not working. We have to again load the images. Okay. Once you are doing reset to the board, and if you are your the binaries are loaded into the RAM, you have to again do the same process. So we are going to do. So now we are with the new image on the boot prompt, and that is called NAM. Can you see?
Yeah, I see.
You can configure the MAC address, from here also. This is the MAC address, right? Oh, it's 00. The prog MAC is the command. You can configure the MAC address too. Do you know about the MAC address? What is the MAC address? It's a
No.
48 bit machine ID or a device ID, the specific ID for every devices that is
Okay.
running on the internet, E- just to identify. Like a SIM, we have a SIM. Okay, if we are connected with the network, and somebody can identify our mobile with the IMI number. Do you know the every mobile have a IMI number just for identification? This is the
Okay.
specific device. If some hardware is something is coming on the network, like our PC have a specific MAC address, the unique MAC address, the no one have the same MAC address in the
Okay.
on the
So
earth.
yeah.
Every device which is coming on the internet, connectivity with the internet, should have a unique MAC ID. That's a 48-bit device ID. Okay. So before coming, you
Okay.
have to be here with the specific ID. So are you getting little bit what we are doing, what side agenda and what we did? Because it's very important. It's very, very important.
Yeah.
So can you bit summarize what we did? And
Sorry.
can you summarize what we did?
Summarize.
Yeah.
Yes, a lot of things. I think yeah, we just um see around the U-boot source code
Yeah.
and load the source code into the ball.
Okay. The basically we
And
did we chose a, a board, okay, based on the ARM SSE, okay,
yeah,
and
yeah,
we have a U-boot, the universal boot code, and we optimize that boot code for our SSE, okay, and we did the toolchain setup, and we compiled that board for our we compiled that U-boot source for our board, okay. We generated the U-boot image, and with the load utility, we loaded that generated image into the RAM memory of the target through the
why
OTC.
don't we why don't we load into the flash memory?
Yeah, of course, we can load into the flash memory also. You want to do this? You want
Yeah.
to load it?
Yes.
See, I'm loading it. Okay. So it's loading to the flash memory. Okay. Now we will reset the board and it should come with the loaded image. It will take few minutes.
Listen, yeah.
Yeah, it's loading into the SPI NOR flash.
So we can either load into the
Yeah,
flash or
yeah,
RAM memory.
yeah. We can do. Now it's done. Okay. So I'm going to do reboot. Okay. It should come again. I did the reset.
Yeah.
It should come back. Okay. One thing I have to do. I have to change the some switch settings. Okay. Let me try it.
Change what?
Change the switch setting, the U-boot switch setting.
Okay.
Now I am going to tell it boot from the the SPI NOR. So for that I have to do some setting. I think I did the wrong settings. Yeah, can you see? Uh, it's flashed. Can you see it?
Yeah, I can see.
It's flashed into the permanent memory. Now we don't need to load it again.
Alright.
Okay. On the background of that I run several commands. Okay. And that commands are, see, I ran this command lft, but on the background of that there are several commands. There are several offsets. Did you saw I try to load on this offset? You want to see it?
What do you mean?
Let me explain it. Can you see this offset and this offset is same?
Okay.
So first I try to load this image on this offset into the RAM memory, okay? And in this step what I said, pick that image from the offset, okay, and load into this offset into the flash memory from 0 to the,
Yeah.
okay. So first I select from the first command, I selected the the flash memory. From the second command I clean that flash memory, and from third command I said, okay, pick that image from this offset and load it from this offset till this offset. This step is clear?
Can you explain again about the
Yeah,
yeah.
good. I will recommend you to do it again on your own at home. Okay,
yeah,
so can you write down? You have to download the source code. Okay, first you have to choose your board. Okay, then you have to download your U-boot, and you have to set the tool chain. Then you have to compile it and generate the U-boot images. Then you have to load that images. Okay, if you want
yeah,
you can note down. And of course you have to connect the board with the host PC. The host PC is the PC right now I'm working. Okay, the
yeah,
host is called the PC I am working, and the target is called the board.
yeah, I know.
Okay, great. So you have to connect the target to the host PC. uh, there must be a two-way to connect. The one, it should be for console and another for loader. That's OTG. That interface is called the OTG. Okay.
Okay,
Yeah. So download the U-boot image, set the tool chain, configure the U-boot, compile it with the correct tool chain and with the correct configuration, generate the binary U-boot.bin and load that binary to the target. Okay. First, I will suggest try to load into the RAM memory. Okay. Why? Do you know why?
I don't know why.
Because you don't know your image would be successful or not. Okay. So you should not load the unsuccessful image into the flash memory. Okay, if you are not able to boot the board,
Okay,
why you will load the image into the flash memory? There is no worth to load that image. Okay, so that's why I'm saying first try to load into the RAM memory. It's successful. Okay, you are able to boot it. Then you should load into the flash memory. Okay,
yeah,
because you are compiling it. It may be. It's not necessary. You will be able to compile it, or you will be able to generate the correct images, or maybe it's corrupted and you are missing something, maybe. Okay, so it's
okay,
recommended you should try to load into the RAM memory first, then you need to flash it.
yeah,
Okay, so I would suggest you try to learn about the ARM. Okay, uh,
yeah,
this chipset. Okay, read about it, read the documentations. Maybe you can read this a specific processor. Okay, you can choose anyone. Okay, but you can select this one, might be, and go through the hardware specification, what they have and how they work and what the functionality they have. And if you want, you can buy this board, or if you have some another board, we can work on that also, not to worry. And if you don't want to buy any board, there are some emulators that is called QMU. Do you know QMU?
QMU. What is that?
Yeah, it's a software emulator for a some board. Okay, some ARM board, ARM SoC. So if you don't want to buy any board, we can work with some emulator also. That's not issue. So if you want, we can set up that also. But I would recommend to go through the boards, choose some any board, because that will give you a real hands-on on some target. So that would be good for your confidence. Okay.
Yeah,
Okay. Uh, what's your IP? What's your IP? You are using
Sorry?
you are using
Please.
some host PC, some PC. Okay. Can you tell me about your IP?
Yeah.
IP address. Can you type this command in your console if config?
Yeah.
Okay. And give me this one. You installed your Linux machine into the virtual machine, or it's a full version?
I think it's a full version.
Okay, that's great. So can you give me this IP?
Yeah.
Where is your IP?
Give you your my IP.
Yeah, IP address.
Um, I think 192.168 dot
Sorry, can you tell me?
50.
Can you tell me?
Sorry?
Can you tell me again?
Um, 192.168
192.168
dot 50.128
50.128.
8.
You are not on a public IP domain, huh? I think it's your local ID.
Sorry?
You are not on a public domain.
It's not public one.
It's not a public one, I think. Okay, so you are not connected directly to the internet. Okay, let it be. Okay, so do one thing. Uh, Try to do this step at your home. Okay,
Yeah.
great. And also you should try to write some code and compile it. And I would suggest you also learn something about the shell script like this. We did.
Sales rep.
Yeah, see what we did. Do you know we what we did? We clubbed all the commands. Okay, we clubbed all the
Yeah.
commands, and we put all that into some file, and that is called the shell script. Do you know the bash file into the window? Do you know the bash file about the bash file into the window?
No.
That file,
Best.
yeah, that file is there. Like if you want to do several steps into a single step, it's called the bash file. Okay, into the window utility. Uh, and the Linux we have a shell scripting. If you want to automate all the systems, okay, see, I clubbed several commands. Can you see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 commands in a single command. Okay. So this is some sort of called automation. I did
Mm.
it.
Yeah.
These things are happening automatically. Okay.
Yeah.
I clubbed here various few commands, but the really when I write, I use several things. Can you see? This is for some real project.
It's kind of function, right?
Yeah, it's kind of functions. Can you see? It's so big.
Yeah.
It's around
I
about 100
see.
lines. Yeah, it's around about 100 lines. It's compiling all the project. So you need not to go and type several commands. Just hit one. Once it would be done. So I will suggest you to go through this also. Okay, like I wrote these commands. So just of your note, I'm sending through the link. Okay. Okay. So uh, I think it's enough for today.
Yeah.
Okay, great.
So do you have any like documents or something for me to follow? It's kind of difficult to follow everything.
I understand. It's very difficult to follow. Right now, I don't have a document, but I will write a document very soon. Okay, and I will share with you. It would be a good idea.
Yeah, can you send to me your document?
Right now, I don't have, but I have to write that document. Okay, so maybe in next class, uh, I will be ready with the document.
All
Okay,
right.
and the next class,
Yeah.
I will able to write it. But I would just recommend you because right, I am working with the Ubuntu and you are working with the Fedora. So if I will write some document just to run on the Ubuntu, it won't be running on the Fedora directly. So you'll face some issue. That's why I said, okay, just be in a sync. So I would suggest just change your OS if you can. Otherwise, we can work on a Fedora also. But maybe if I will write something in a document, it won't be running on your OS directly. So you have to do some modification, some extra exercise. Are you getting my point?
Oh yeah.
So that's why
Yeah. Yeah.
if you are in a sync, then it just you have to do copy and paste and it will work. But if you are not in a sync, then you have to do some exercise. So I would suggest just install Ubuntu 14.04. It's very easy.
Ubuntu.
Yeah,
Okay.
that's
All right.
14.04. Okay.
14.04.
Yeah. So that would
So
be a great.
can I install two Linux operating system in the virtual machine,
You
or I have
can
to delete one?
you can, but I would recommend you just install the full version. Okay. So because in a virtual machine you have to do some settings for the internet, and that would be difficult for you. Okay. There are some settings for Ethernet might be you will not able to do it. Okay. And you cannot share your screen to me so that I can correct it. So that's why I would suggest you just install the full version. Okay, it would be quite simple, very simple. There are several tools,
Yeah.
that is called you can make your USB bootable for the Ubuntu. There is some tool in the window. You can, with the help of that, you can make your USB as a bootable, and you can just flash your Ubuntu into the USB, and you can boot from there, and you can download. That's very simple step, I think.
Yeah.
So that you can follow. And then if I will give you a direct command, it would be working on your PC. That would be quite fine for you.
Sorry.
If you will be up with the Ubuntu, if then I will give you commands like this, and that would be running directly in your PC. So need not to worry about. So
Yeah.
that's important, very important. Okay, so uh, when we will doing the next class?
I don't know yet.
Okay. Mm, uh, I have to took a class in I think Wednesday. Wednesday. So the next class will be on a Wednesday or Thursday
Wednesday, yeah.
or Thursday.
Yeah.
Thursday.
Thursday.
Yeah, ninth of June at 8:30.
Alright, alright.
Yeah, great. So come with the Ubuntu PC, and I will make some document on this steps and about the
Yeah,
shell scripting also. Okay,
yeah.
okay. So that would be good. Okay. So
Alright, alright.
all right. Okay. So I'm closing this class today, and we'll meet again on Thursday at 8:30. Yeah.
Okay, okay. Yeah, thank you.
Thank you. Bye.
Bye.